All right, so you're a programmer, and you want to wrap your head around this DCGN paper,
Okay.
but you don't want to become like a full-blown AI expert, right?
Right.
So you've come to the right place. We're going to break down this paper, Unsupervised Representation Learning with Deep Convolutional Generative Adversarial Networks.
Yeah. It's a mouthful.
It is a mouthful, but think of a GAN,
Uh-huh.
like two neural networks.
Yeah.
One's generating these images,
Okay.
the other one's judging how real they are.
Right.
And this kind of back and forth is what pushes them both to get better.
So the DCGAN paper introduces a specific type of architecture for these GANs,
Okay.
and it uses convolutional neural networks, which are really great for image tasks.
Right.
And they make some very specific design choices to make sure that the training process is stable.
Gotcha. So you're saying it's like the behind-the-scenes optimizations that help these networks actually learn effectively.
Yeah, exactly.
So they built this system, but what did they actually train it on?
So they used a couple of different data sets. One of the main ones was LSUN, which is this huge collection of bedroom images.
Okay.
And to make sure that the network wasn't just memorizing the images,
Right.
they actually deduplicated the data set.
Interesting.
So that ensures that the network's actually learning the underlying patterns and not just regurgitating the specific pictures it's seen.
So it's like making sure a student understands the material instead of just memorizing the textbook.
Exactly.
Okay.
They also used a data set of faces, and they also used ImageNet, which is this massive data set of general images.
Right.
And that let them see how well this DCGN could learn from different types of visual data.
I see. So how do they know if it was actually learning anything useful?
Well, they tested it out by using it as what's called a feature extractor for image classification tasks.
Okay.
So they took the DCGN and they said, okay, let's see if you can help us classify images you've never seen before
Interesting.
from other data sets. So they use data sets like CFAR10,
Mm-hmm.
which has pictures of like cats and dogs, and SVHN, which has house numbers and things like that.
So they trained it on one set of images and then tested
Mhm.
its ability to understand completely different images.
Exactly.
Okay.
And the results were pretty impressive. The DCGN performed really well on these tasks, which suggests that it was actually learning something about like general features of images.
Yeah.
It wasn't just memorizing specific examples.
That's really cool. But the paper goes deeper than just classifying images, right? Like they
Mhm.
actually try to look at what's happening inside the network.
Right. They want to know, how is the DCGN representing images internally?
Okay.
So one of the things they did was explore what's called the latent space.
Okay.
So this is where the random noise that gets fed to the generator lives.
Right.
And you can think of it like this map of all the possible images that the generator could create.
Gotcha. So by exploring the latent space, they could see how changing the input would affect the image that came out.
Exactly. And what they found was that as they moved through this space, the images that were being generated would change really smoothly. So they could take an image of a bedroom without a window and slowly transform it into a bedroom with a window.
Wow.
And that suggests that the network was learning some kind of structure or logic about how these images are composed.
It's like the DCGN was developing its own understanding of what a bedroom is without being told what a bedroom is.
Right.
That's really neat.
But they also wanted to look at the discriminator,
Right.
which is the part of the network that's judging if the image is real or fake.
Uh-huh.
And they were able to visualize which parts of an image were activating specific features in the discriminator.
Oh, so they were essentially figuring out what the discriminator was looking at to decide if an image was real or not.
Exactly. And what they found was that certain features would consistently activate on certain objects, like beds and windows in the bedroom images.
Okay.
So it's like the discriminator had learned to pick out those key elements of what makes a bedroom a bedroom.
That's fascinating. It's like the network was learning its own version of what a window or a bed looks like all on its own.
And those architectural choices that we talked about earlier probably played a big part in allowing the DCGN to learn those robust representations.
So they basically gave the network the right tools for the job?
Yeah.
But they didn't stop there, did they? They actually wanted to see how much control they could have over the images the generator was making.
Right. So one of the first things they tried was to see if they could get the generator to forget how to draw windows.
Forget how to draw windows. How do you do that?
So what they did was they manually identified windows in a bunch of images,
Okay.
and then they trained a classifier to say, okay, which features in the generator's output are associated with windows.
Gotcha.
And once they knew which features were responsible for drawing the windows, they went in and they removed those features from the network.
And did it work? Did it stop drawing windows?
It's pretty amazing.
Okay.
It mostly stopped generating windows in the images.
Wow.
And it even started replacing the windows with other objects that made sense in the context of a bedroom,
Really?
like doors or mirrors.
So they were basically controlling what the generator was drawing by
Hmm.
tweaking these internal representations.
Exactly.
That's incredible. What else did they do?
They took this even further and used what's called vector arithmetic
Okay.
in the latent space to control the generated images.
Wait, vector arithmetic with images? How does that even work?
So it's based on this idea that different features of an image are represented by specific vectors in this latent space.
Right.
And they found that you can actually add or subtract these vectors to manipulate the output image.
Okay.
So for example, they took the vector for king, subtracted the vector for man, and added the vector for woman, and the resulting image looked like a queen.
Whoa. So they could combine these like conceptual building blocks to create new images.
Exactly. And they found that they could add or remove objects from a scene
Okay.
or change facial expressions all using this method.
Wow. So they had like really fine-grained control over what the generator was producing?
Right.
This is starting to sound super powerful.
Yeah.
What are the bigger implications of this research?
Well, the important thing here is that the DCGAN wasn't explicitly programmed to recognize objects or to manipulate images in these ways.
Right.
It learned these representations on its own just through its interaction with the discriminator.
Okay.
And that suggests that GANs and DCGANs specifically have this incredible ability to learn from data that doesn't have like neat labels attached to it.
Right.
So we call this unstructured data.
Gotcha. So what does all of this mean for like me, a programmer who's not necessarily an AI expert?
Well, if you work with images in any capacity, understanding the concepts behind DCGANs can be really valuable.
Okay.
They give you powerful tools for things like image generation, editing, even feature extraction for other machine learning tasks.
Yeah, that makes sense. This has been a really amazing deep dive into this DCGAN paper.
Yeah,
It's incredible to see how this research is really like pushing the boundaries of what's possible with machine learning.
definitely.
Before we wrap up, are there any like key takeaways you'd like to emphasize for our listener?
Yeah, I think the DCGAN paper really shows us the potential of GANs for this unsupervised learning, and image generation in particular.
Right.
It demonstrates that with the right architecture and the right training data, GANs can learn these really complex representations from data
Yeah.
without us having to like hand label everything for them.
Right.
And that opens up a ton of possibilities for applications,
Yeah.
even beyond computer vision.
And to think this paper is just like the tip of the iceberg when it comes to GANs.
Exactly.
But before we go too far down that rabbit hole,
Yeah.
I want to leave you with a thought-provoking question.
Okay. Shoot.
Remember that concept of vector arithmetic in the latent space?
Yeah.
Where we could manipulate the generator's output by adding and subtracting vectors representing different concepts. Could we apply this concept to other types of data beyond images?
That's a really interesting question.
Like what about music
Yeah.
or even code?
Imagine training a GAN on a massive data set of code and then using vector arithmetic to modify the functionality or the style of the code snippets that it generates.
That's a really wild idea.
It is, but who knows? Maybe someday we'll be using GANs to help us write our code.
That's awesome. The possibilities really are endless.
Yeah,
That's the beauty of this kind of research.
it really is.
It opens up these new avenues for exploration.
Yeah,
It pushes us to think differently about the world around us.
absolutely.
Well, on that note, I think we'll wrap up this deep dive into the DCGAN paper.
Okay.
We hope you've enjoyed this journey into the fascinating world of generative adversarial networks.
Thanks for listening.
And until next time, happy coding. We've really gone deep with this DCGAN paper, huh? Talked about how it learns what it can do, even how researchers can like peek inside and change things up.
Yeah, it comes down to this idea of representation learning. The DCGAN, it figures out what makes an image all on its own.
Without us humans having to label everything for it.
Right.
And for our programmer friend listening, this might get their gears turning, even if they're not like AI experts themselves.
Exactly. It's about the principles.
Yeah.
DCGANs, they show us a new way to think about data. It's not just pixels anymore. It's vectors capturing these concepts.
Okay.
And this goes beyond images, even though that's what the paper was focused on.
And that's where we leave you, dear listener, with that seed of a question. Could this work for code music? Any data someday? This paper is a step, not the whole staircase.
Keep that exploration going. Keep coding, and who knows what you'll find. That's what this deep dive's all about, giving you the tools to think bigger.
Absolutely. Well, on that note, we'll wrap up our look at the DC Jam paper. Hope you've enjoyed this trip into the world of GANs.
It's a fascinating world.
It really is. And until next time, happy coding, everyone.